Let's begin by coming up with a definition for hypothesis testing. Hypothesis testing is defined to be a way to evaluate a claim that someone makes about a population. For example, say that we see in a magazine that the average cost of a DVD player is $79. That statement is someone's claim, maybe based on some research, but it's still someone's opinion about the cost of a DVD player. Our job in hypothesis testing is to decide whether or not we agree or disagree with that statement, and then statistically be able to prove it or disprove it. So do we agree or disagree, and how do we go about making the decision? If we were trying to decide what the average cost of a DVD player was, we would determine a sample. We would look at the prices of those DVD players in our sample. We could calculate an average, and we would compare it to the $79. So, for example, we could choose a sample of 100 DVD players. We could calculate our average price and then compare our average to $79. When we go through the process of a hypothesis testing, the first step is to write the null and alternate hypotheses. You're going to have two hypotheses for every problem that you work. So let's look at them one by one. The null hypothesis is denoted by H sub 0. The null hypothesis says that there is no significant difference between the two values. By this we mean, if you think back to the example that we just looked at with the DVD player, the claim was that the average cost of the DVD player was $79. So we've already talked about how we would check that. We would do our own research. We would come up with our own sample. We'd calculate the average cost of the DVD player in our sample, and suppose we find it to be 78. Right? So we're going to end up comparing the 78 that we come up with to the 79 that is the stated average. Okay, this 78 that we come up with, that is based on our sample. And so this is the sample mean. Right, that 78 comes from our research, from our sample. That's our sample mean. The $79 is the accepted average, accepted mean. And that's going to play the role of your population mean. And so when we talk about the null hypothesis saying that there's no significant difference between the two values, we're talking about no significant difference between the population mean and the sample mean. So in this case, if the population mean is 79 and our sample mean is 78, we would probably conclude that that's not a significant difference between the two values. All right, the alternate hypothesis is your other hypothesis, denoted by H1. And the alternate hypothesis says that there is a significant difference between the two values. So it basically says that the population mean and the sample mean are significantly different. So going back to our DVD example, the claim, remember, was that the average cost of the DVD player was $79. Okay, so there's your population mean. And suppose that when we did our own research, we find the average cost of the DVD player to be 58. So when we compare the sample mean to the population mean, we would conclude that there is a significant difference between those two values. And that's what the alternate hypothesis says. So let's look at a couple of examples and talk about how you write your null hypothesis and your alternate hypothesis. So our first example says, a researcher thinks that if expectant mothers use vitamin pills, the birth weight of their babies will increase. The average birth weight of the population is 8.6 pounds. So think about how you would approach this if you were the researcher. You would come up with a group of expectant mothers, that would be your sample, you would give those mothers the vitamin pills. And when the babies are born, you would check the birth weight of the babies and calculate an average. And then you would compare that average to the population mean of 8.6. Okay? So what we need to do is we need to key in on the fact that the researcher thinks that the vitamins will cause the birth rate weight to increase. Okay? So what that means is that in terms of mathematical notation, what that means is that he thinks that the average, and an increase means that it will be greater than, he thinks that the average will be greater than 8.6 for those women who are taking the vitamin pills. Okay, now when you're writing your hypotheses, when you write the null hypothesis and the alternate hypothesis, between the two hypotheses, you have to have included every possible outcome. So if one of your hypotheses has a greater than in it, in order to include every possibility, the other hypothesis has got to have a less than or equal to. And therefore, between your two hypotheses, you've included every possibility. One is greater than, one is less than or equal to, and that is all your options. Okay, once you get your hypotheses written, then you need to go back and you need to label which one is the null hypothesis and which one is the alternate hypothesis. Remember that the definition of the null, right, the definition of the H sub 0 says that there is no difference between the values. All right, well, what does no difference mean? No difference means that they're the same. In other words, that they're equal. And so looking at your two hypotheses, whichever hypothesis has the equal to option in it, by definition, has to be the null hypothesis. So in other words, this one should be labeled H sub 0. Because it has the equal to option, right? Which sort of by default makes the other one your H sub 1. And so the key there, 2 hints. The first hint is to remember that you got to consider every option. So if one is greater than, the other one would have to be less than or equal to. And the other hint is to look for the one that has the equal to sign and know that that one always has to be the null hypothesis, because the null hypothesis by definition says that there's no difference between the two values, that they are equal. All right, let's look at another example. Let's say that an engineer hypothesizes that the mean number of defects can be decreased. Okay, so I'm going to key in on that. In a manufacturing process of compact discs by using robots instead of humans for certain tasks. The mean number of defective discs per 1,000 is 18. Okay, so the engineer thinks that the number of defects can be decreased, which tells me that one of my hypotheses should look like the average being less than, and the accepted mean is 18, so less than 18. Again, you got to have every option. So if one of your hypotheses is a less than to show the decrease, then the other one is going to need to be a greater than or equal to. Okay, once you have your hypotheses written, then you go back and you label them H sub 0, H sub 1, remembering that the null hypothesis has the equal to sign in it. Right, so that would make this one your null, and this one your alternate hypothesis. Okay, one more example. A psychologist feels that playing soft music during a test will change the results of the test. Okay, The psychologist is not sure whether the grades will be higher or lower. Okay, so all he's really thinking is that it's going to change it. In the past, the mean of the scores was 73. Okay. Now again, remember that the null hypothesis says that the numbers are equal. It says that when the psychologist does his research and comes up with his sample and calculates his average, that sample mean and this population mean are equal. And so one of our hypotheses is going to be that the average is equal to 73. Okay? That's the case where the playing the soft music does not change the results of the test, that the average stays at 73. The other possibility is that playing the soft music does change the results of the test, in which case the average is not equal to 73. It's different. Right, again, you have every option listed there. You've got the equal and the not equal. Because it says he doesn't know whether it's going to be higher or lower, precludes us from actually going in and doing a greater than or less than. We can't show both of those in the same statement. And so the only way to write this one, if he doesn't know if it's going to be higher or lower, and he doesn't really care, he just wants to know if it's going to change it, is to write it as an equal or a not equal to option. All right, again, null hypothesis always has the equal to part in it. So that first one will be the null, and the second one will be the alternate hypothesis.